So, this is our embedded project. So we are our project is basically water management system, and how we are going to show our demo is basically like we have basically imagine there are three tanks. Like there is Bangalore tank, the main city tank from where the supply is coming to ISC. The first one is Bangalore tank. So the water is always available here, and this is assumed as a Bangalore tank here. The second one is basically the ISC college tank. So this is here, and the third one is basically the desert tank. So this is shown here. So basically our project is like this. Like imagine if the Bangalore supply water supply is always there. So we need to uh, uh, basically preserve the water and do not waste water even when the tanks are filled. So basically what we are doing here is like so whenever the ISC or desert tanks are filled, so basically it gives the signals to the preceding stage to stop the water supply, so that it doesn't get overflow. So that's the whole point of the project. So similar here also, if the desert tanks overflows, it will send a signal to the ISC tank to stop the motor flow. So it is all are working parallelly. So it will preserve water and it won't waste water. So that's the whole point. So in this project, basically, for so basically here, what we will do is first we thought that we will take three TIVAs for each tank to control the motor and basically the flag. But we optimize the solution to only one TIVA board, and we use three ESP8266 boards for each tank and one ESP8266 extra for server. So the basically the TIVA was for the middle one for the ISC tank, because it has two purpose basically, because it will first of all it will take the data from the desert tank, whether it is underflow or overflow, and also it will sense the its own distance of water using ultrasonic sensor. So TIVA is necessary only for the middle tank. No requirement for first and third tanks. So that's the optimized solution. So and how we are doing basically that we are creating a client server model for ESP8266. So if you can see here. So this is the server. So this is the server created, and these are the two clients. You can see here the values. Basically, these are the values stored in the buffer in the server. It is sending to the different ESP, and here you can see basically the data. You can see there is 000, so the motor is off, and basically when it changes to 1, the motor will get on.
Assume that what now assume that water level is like upper level, I am assuming. So when it reaches to lower level, the motor will get turned on. Here you can check that we are sending one flag, and on the this side, other side, it is getting motor turn on. Right now our motor will start on. Here you can check. See. Now it will reach to certain level, upper level. After that it will get turned off.
पाँच मिनट
Now it's sending 0 flag that motor should turn off after some time. Yeah, we are getting that 0, and here you can see that motor is turned off after reaching certain level.